In this video, we're going to look at solving quadratic equations by completing the square. Now, in this example, certainly what you probably want to do here first is try to solve this one by another method, like, for instance, factoring factors of 20 that would add to give you 12 or negative 12 would be negative 10 and negative 2. But for the sake of learning how to complete the square, let's do this one by completing the square. So mainly when you want to complete the square is when it cannot factor. Now, first thing, if you don't have a leading coefficient, or if you do have a leading coefficient, you have to divide that leading coefficient through the problem. We'll do that one in a harder example, but if you'll notice, this one doesn't have one. So what we're going to do is pretend that this one doesn't factor, and so what we're going to do is we're going to subtract this value over to this side. So we'll get x squared minus 12x, and what we're going to do is we're going to always add some other value, and of course we said this would go to the other side, so this would be negative 20. In other words, we're subtracting 20 from both sides. And whatever value, this mystery value that we had on this side, we're also going to add it to this side. Now, this step is actually called completing the square. And when we add this value, it's always add, it's never subtract. And what we're going to do is we're going to add something that will make this factor. And it will make it factor to a perfect square trinomial. If you're not sure what a perfect square trinomial is, kind of look that up. You don't really have to know it. Now, to get this value that completes the square, what you do is you look at this term right here, which is called the linear term. So it's negative 12. And really the fact that it's negative or positive right here does not matter at this point. So really you can just say 12. So what you do is you take this value and you half it and square it. Okay, so that's probably one of the things that you write down in your notes. Take this value and you half and square it. Now, because you're squaring it, that's why it really doesn't matter if it's positive or negative. So even though it's negative 12, I'm just going to say 12. Now, half of 12 would be 6, and then 6 squared is 36. So again, you half and square. Half of 12 is 6, and 6 squared is 36. Now, if I add 36 on this side, and we just can't add something to an equation wherever or whenever we want, we also have to balance that, so we have to add the 36 to this side. And now what this has done is created a perfect square trinomial. So it will factor to a quantity squared. Now, if we were just normally factoring this, we'd say factors of 36 that add to be 12 would be 6 and 6, actually negative 6 and negative 6. And so we would get x minus 6 times x minus 6. But instead of writing as x minus 6 times x minus 6, we'll write this as x minus 6 quantity squared. And so you really don't have to do that method when it's a perfect square trinomial. And it's always going to be a perfect square trinomial when you complete the square. And so the shortcut to that is just to take the square roots of the first and last terms. See, the square root of x squared is x, the square root of 36 is 6. And whatever sign this is the one that you're going to use in your factor. Now let's combine these terms over here, negative 20 and 36. Would be a nice positive 16 there. Now, so at this point, really what we can do, since this is a quantity squared, is now we can use the square root method. So the whole point of completing the square is to get a perfect square trinomial to a quantity squared. And now we can just simply take the square root on both sides. So the square root will undo the square, and so this will just be x minus 6. Now, because we're taking the square root on both sides, what can I square to get 16 would not just be 4, but it would be plus or minus 4. Okay, so anytime we take the square root on both sides, this is going to be plus or minus. Now, we're just going to add this 6 over to this side. So we're going to add 6, so it would be positive 6 plus or minus 4. And so what happens is this gives us two answers here. So we can do 6 plus 4 and 6 minus 4. And a lot of times people write those out. I usually don't write that out. So 6 plus 4 would give me 10. And then 6 minus 4 would give me 2 there. Now, let's look at another example here where remember this one could have been factored. And because it factored, this kind of came out to a perfect square right there. And so I got two really nice answers. Now let's look at an example where this is not maybe going to be a perfect square. So example 2 here. Notice again, we don't have a leading coefficient. So if you do have a leading coefficient, what you do is you just divide through by that leading coefficient to get rid of it. Now, first thing is we're going to get rid of this value. Notice that this one would not factor at all. Factors of 10 that subtract to be 8. There are no factors of 10 that subtract to be 8. So this one you'd have to use the completing the square method or the quadratic formula. Now, let's get rid of this number, and we're going to put a number in the place that makes this factor. So this gives me x squared plus 8x. Now when we add this little mystery number, we're just going to put a blank right here. I'm going to transpose this 10 over, so since I'm subtracting 10, I would just add 10 to both sides. So that means it would be positive 10. And then whatever I'm going to add right here, I have to add to this side also. Now, let's complete the square. So when we complete the square, again, you take the linear term, that's your middle term right here, and you half it and square it. So if we take half of 8 would be 4, and then 4 squared would be 16. So half of 8 is 4, 4 squared is 16. Now if I add 16 here, then I have to add 16 here so I can get a balance. Now, this is going to be a nice perfect square trinomial. So it's going to factor to a quantity squared. There's two ways to do that. You can say factors of 16 that add to be 8 would be 4 and 4. Or just simply take the square roots of these two values and use this sign. So any way that you look at that, that would be x plus 4 quantity squared. Now over here, 10 and 16 would give me 26. Okay, now notice that that's, like we said earlier, not a perfect square like in the last example. Now we're going to get rid of this square by doing the square root method here. We'll take the square root on both sides. So the square root will just undo the square. And now just like last time, we took the square root on both sides, so this means this could be a positive or a negative value. Now notice that 26 is not a perfect square. There's not a perfect square that goes into it, so we can't simplify it. So that's just going to be left as square root of 26. So this answer is not really going to be as nice as the other one. Now we only have one thing left to do here, so we're going to subtract 4 from both sides. And so I'm just going to transpose this over, and usually it's just sort of conventional that this value goes in front instead of behind. It really doesn't matter. But this will be negative 4 plus or minus the square root of 26, and that's my answer. So notice on this one, since this was not a perfect square, I really didn't get two nice values. Now, just for the sake of if you're doing one here where it maybe doesn't work with a number like this, I always like to play a game. It's called What If. Okay, for certain situations that happen. So what if we would have gotten, say, negative 4 plus or minus the square root of 28 instead? Now, I know that's what we didn't get there, but if you do run into that situation, in this case, we should probably notice that the square root of 28, unlike square root of 26, square root of 28 simplifies. Okay, so when you simplify a square root here, again, that's probably just a whole other lesson that we could talk about by simplifying square roots, is we look for a perfect square that would go into 28. In that case, a perfect square that would go in a 28 would be 4. So I could break that down to 4 times 7. And now we can say the square root of 4 is 2. So we would get negative 4 plus or minus, that would just be a 2, and then 2 roots of 7 there. Okay, I'll have two other examples here, examples 3 and 4, where they'll be a little bit more difficult. So you'll notice in these two examples that I chose an even number for the linear term because we halved and squared. So we'll look at what happens when that's not even and it doesn't work out quite as nice there.